Hello, this is a video for lesson 9.3, and I'm going to show you examples 3 and 4 again, kind of typing things in ALEKS and how we would work that out. And then also I'm going to show you an ALEKS example to help as well. So you've already seen 3 and 4 done in the video, possibly using the Desmos program. So we're going to verify that those are calculated correctly. So we have two companies, A and B, and we wanted to compare them because it says that we think that company A retains their workers longer. So that would be a larger number for A. So essentially, I'm just kind of summing things up. Are the population standard deviations known? No, we only have sample standard deviations. So that's why we have to use the t-distribution. Conduct an appropriate hypothesis test. So we have H0, H1. And so we're testing that the means are equal to each other. That's what we're assuming. But we are really testing that 1 is bigger than 2. That's step 1. Step 2 is they want us to test at the 5% level, so 0.05. And then our third step, which is the most important, is the test statistic. And this is the, I don't want you to look at this other stuff. This is the test statistic. It's hard to read in the notes, so this, I want you to write this down. This part right here is usually going to be 0 because we're assuming that there's no difference. And so we really just want the sample mean difference, and then divided by the square root of the variance of sample 1 or the standard deviation squared. So if you're given the variance, ALEKS likes to give the variance because remember that this is variance. So if you square the standard deviation, it's the variance, and that's just the standard deviation. So if they say this is that they give you the number that's the variance, you can just type that right in. Divided by the sample size of 1 plus the variance of sample 2 divided by the sample size of sample 2. And then the degrees of freedom are the smallest of the two divided by 1. I'm sorry, subtracting 1. So whichever is smaller, the two sample sizes, whichever is smaller, you're going to subtract 1. So let's go ahead and calculate this. So that means we have their average time is 5 years for A, and it was 4.5. So 5 minus 4.5, subtracting 0, divided by, and then you were given standard deviation here. So we're going to square that, divided by the sample size of 15 minus the standard deviation squared divided by the sample size of 20. And so our degrees of freedom is going to be 15 minus 1 or 14 because our smallest sample size is 15. So just for ease of use, I'm just showing you what I'm going to type in Desmos here. This is what it's going to look like in Desmos. Okay. And so if I go to the ALEKS, that's what it's going to look like in ALEKS. So my goal is that I'm going to type it right here. So I want you to see how it would look like in ALEKS. So you're going to do parentheses 5 minus 4.5, and then you can subtract 0 if you want. So we need to have a big parenthesis here. So you don't even have to subtract 0, but that's just showing that that's what the difference should be in the population, even though we're testing that it's not. And then a square root of, and then my 1.2 squared, and then arrow right, so you can divide by the sample size of 15, arrow right to add, and then 0.8. You have to raise that to the 2 again, arrow right to go down, and then divide by 20. and then hit enter. And then this is your test statistic. It's 1.3975. And then we are testing a greater than, and so that works out. That's what the T is. It's a greater than. So I'm going to clear that out. If it were a less than, we would have to do 1 minus that, but it's a greater than. So it's 1. My test statistic is 1.3975, and then arrow over, and my degrees of freedom is 14, and we're going to hit enter, and this is the p-value. Which is 0.0920. And I'm going back to my paper. And you can see that's my p-value. So remember that we can either do our test statistic or the p-value compared to alpha. So 0.05, and my p-value is 0.0920. And so since it's greater than that, we would not reject H0. So we can't say that there's a difference. And we saw that in the lesson as well. So let's look at question number 4. It says a study is done by a community group in 2 neighboring colleges to determine which one graduates students with more math classes. College A has a sample size of 11. Their average is 4 math classes with a standard deviation of 1.5. Class B has sample of 9 graduates. Average is 3.5, standard deviation is 1. The community believes that the student who graduates from college A has taken more math classes on the average. Okay, so again, I'm just looking at my hypothesis here. We're testing that they're equal, but we think that A has more than B. So it's another greater than in this case. Okay. Both populations have a normal distribution. Test at the 1% significance levels. That means in step 2 here, we have an alpha at 0.01. And it says, is this a test of 2 means or 2 proportions? So that would be 2 means. And we are unknown on this population standard deviations. And so that means we should use the T distribution. So let's calculate our test statistic here. We are going to use 1.5 subtracting 3.5 subtracting 0 all over. Oh, whoops. Sorry. That's 4 minus 3.5. Their standard deviation is 1.5 squared divided by 11 plus has a standard deviation of 1 squared divided by they had 9. So that means our degrees of freedom is going to be the smaller, so 9 minus 1 or 8. It should be 4 minus 3.5. Sorry about that. Okay, so again, we're going to take a look at this here. And this was that's from example 3. So we already put that in. So we're going to ALEKS. So in ALEKS, there we are. So I'm just going to adjust this. So if I can edit it, it's a lot easier. And that was 11. And that was 1.5. 3.5. So there is my test statistic at 0.8899. And again, it's a greater than. So we are going to just figure this out and do a greater than, and it's 0.8899. And degrees of freedom, we said was 8. And so there is my p-value is 0.1997. And alpha this time is 0.01. And it's a greater than, so we do not reject H0. P-value is here, 0.1997. And we're testing this test statistic. Okay, so we do not reject H0. So there is not significant evidence to say that college A grads take more math classes. We can't say that. So that's example 4. Well, now I would like to take us to an ALEKS. I want to show you how one works in ALEKS here. So I'm going to go back to my screen for a moment here, and I'm going to show you this ALEKS example here. So it says, using the latest in medical technology, an orthopedic doctor has developed a new surgical procedure that he believes is an improvement over the standard procedure. He wants to study whether the mean recovery time of patients who have had the new procedure is less than the mean recovery time of those who have the standard procedure. By the way, this is at the end of the chapter 9 notes in the link in the modules. So you might have the printed out course pack. This example is a new example. So if you just click on the link for the modules for notes of chapter 9, it's at the very bottom, and you could just print this out so you have reference on how to type them in to ALEKS. It says the doctor studies a random sample of 11 patients with the new procedure and 10 who had the standard. And then here is the mean, and notice that they give you the sample variance, not the standard deviations. So we're going to write those down. I'm going to document all of those. I suggest you do as well. And then it says, assume that the two populations of recovery time are approximately normally distributed. Can the doctor conclude at the 10% level of significance that the population mean of recovery times of patients who have the new procedure is less than the population mean of recovery time of those that had the standard? So then I am going down here, and this is what I have it typed in ALEKS here. Now to type mu1 and mu2, mu1, you'd have to click on where my mouse is here and tell it that you want to have a little subscript. And then you click on the mean, the population mean, and then you take a right, and then you can just put a 1 there as a subscript. And then you go arrow right and put an equal, and then click on it again, and it will be a mu2. And then you're going to tell it's a less than because they asked for a less than, and it's a T. And then our degrees of freedom is 9 because our smallest sample size is 10. So 10 minus 1. And so if you scroll down, this is what it's going to look like in ALEKS. And then this is what our test statistic is. And to get the p-value, you're going to type on in the ALEKS calculator. You're going to go here and you're going to type the test statistic. And because it's a less than, let's start over. Because it's a less than, we have to do 1 minus the greater than. So, and then the test statistic is a negative 1.9169. Don't forget that it's negative. And our degrees of freedom is 9. And there is our p-value 0.04374. I typed in as much as I can because then I know it's accurate. And because our alpha is less, or because our p-value is less than the alpha of 0.10, we do reject H0. We can conclude that. So there is an example from ALEKS. Now, if I show you one from ALEKS here, and we try another, I'm just going to kind of show you the setup. I'm not going to go through the whole thing, but clicking on this mu here, we want to test, it says perform a two-tailed test. So that's something we'd have to put in, but I'm going to click on this subscript and then I'm going to put mu there, and then I'm going to arrow right to put a 1, and then I'm going to arrow right again and put an equal, and then I'm going to hit the subscript again and the mu and arrow right to put a 2. And then down here, I would do the same. Mu, arrow right 1, and then arrow right. And then I need a not equal symbol. So I'm going to choose this right here, the not equal to, and then my subscript, my mu, and my 2. And of course, we're using the test statistic T, and then we'd have to, and then the degrees of freedom, you always look to see which one has a smaller sample size. It looks like there's a sample size of 11 and 13, so the degrees of freedom would be 10. And it says find the value of the test statistic. So we could just type it in. So let's just do it while we're here. So it says 109.7 minus the 146.8. And I'm not going to subtract 0 because it's just more steps. And then I'm going to take the square root of, and they gave us variance. So that's the cool thing, is we don't have to square anything. So 246.2 divided by my sample size of 11 over plus, and then my other variance was 1352.9 divided by 13. And my test statistic there is a negative 3.2992. And now that's really far away. So I'm guessing we're going to reject either way, but we have to find the p-value anyway. So this is a not equal to. So that means I'm going to do the two different critical values here. So we can find let me see, I gotta find this here. So to find the critical values, we're going to click on the T alpha. Whoops, I gotta clear all that out. So T alpha, and remember our alpha is divided by 2. So they wanted us to test at the alpha 0.01. So that means we're using 0.005 because we have to divide by 2, and our degrees of freedom is 10. And so they're plus or minus, so 3.169 and a negative 3.169. And we are still going to reject because we're definitely outside of that. So it says at the 0.01 level of significance, can the engineer conclude that there is a difference between the mean yield of tomato plants grown with add 1 and the mean yield of tomato plants grown with add 2? And we can say yes. And we are correct. Let me know if you have any other questions.